Welcome to this video on GPU and AI infrastructure management with AMI Data Center Manager. In this video, we'll explore some of AMI DCM's features that address some of the most common challenges in managing dense heterogeneous AI environments. AMI DCM is a powerful software solution that efficiently manages different compute environments, including dense NVIDIA GB200 AI racks. It collects vital telemetry and data from the rack's components regardless of their type or vendor. This includes the compute trays and their CPUs, GPUs, drives and memory, and any storage, networking, power, or cooling devices. AMI DCM analyzes and aggregates that data and presents it to administrators through its web interface. Moreover, its RESTful APIs, Apache Kafka data streaming, and iframe integration options allow its capabilities to be integrated into other solutions as well. AMI DCM's customizable dashboard is designed to give you a holistic high-level overview of your data center environment. Let's get to managing your AI clusters. From the dashboard, you can quickly get to an AI cluster through the hierarchy. When you click on one of the racks, it will show you critical information including the number of devices in the rack and the CPU, RAM, and drive space details. The rack's total power consumed relative to its maximum power capacity. The rack's power consumption, carbon emissions, and temperature over time. The health status of the different components and subcomponents in the rack. The facility power and PUE relative to the rack's power consumption over time. And a list of the events that occurred that may require attention, as well as their statistics. You can also see a visual of the rack and components on the right-hand side of the screen, including compute trays, NVSwitch, and power shelves, all color-coded by inlet temperature or health. You can use 2D blueprints of the rooms and place racks in them accordingly for a more accurate visual representation of your environment. In this layout view, racks can be color-coded based on their average inlet temperatures, or based on other parameters such as power consumption, space utilization, or health. The components in the racks can also be color-coded according to similar parameters. From here, you can switch to a row view to see the front of the racks in that row. You can then select a specific device of concern to go to see its details. This view lets you quickly detect potential causes of thermal issues, such as hotspots or hardware health problems. Clicking on the system, you can see its type and model, serial number, BMC IP address, its capabilities, firmware versions, and the link to its management console. You can also see a summary of its power consumption, temperature, as well as the number of CPUs, RAM, and hard drive space. You can also see its details including its processors, memory details, storage, and GPUs. The health status gadget shows the current health of the different subcomponents. This server clearly has GPU thermal health-related issues. The fault history allows you to see when different issues started to happen. You can also see the device's overall power consumption, carbon emissions, and temperature over a period of time. AMI DCM can also show the GPU power, temperature, utilization, and memory utilization over time, either all together or individually. Finally, you can see the device's overall utilization and SSD drive details, estimated SSD lifespan, and event log. Since we identified that the GPU was having health issues, we can go to the Reliability tab, click on GPU, and see the list of GPUs and respective health issues. For example, let us choose a single GPU that is facing an issue and reset it. To do so, select the faulty GPU and click on Add Task. Give it a name, and choose Reset from the task types. Similarly, DCM allows you to perform such tasks for GPUs in batches. Simply select the GPUs that you wish to perform a GPU management task on. Then click on Add Task and give the task a name. For example, set limit and choose from the options which task you wish to run. For this example, let's set a power limit of 400 watts on these 3 GPUs. Effectively managing cooling is another key aspect of AI infrastructure management. AMI DCM leverages onboard thermal sensors from each device to generate granular thermal views, eliminating the need for additional external sensors. Navigate to the Sustainability tab, then select Cooling Analysis to analyze the cooling efficiency across different rooms housing your AI infrastructure. The cooling analysis shows a histogram-based distribution of the temperatures of the devices in different rooms. Here we see that there are a few devices running hotter than the rest. Clicking on the red bar reveals that there is an issue with a cooling unit in that room. The color coding and hotspot identification convention is based on the selected ASHRAE cooling criteria. With liquid cooling becoming essential for AI environments, DCM helps detect issues in cooling units and CDUs, such as leaks, low reservoir levels, pressure imbalances, and pump failures. These issues can lead to overheating, performance degradation, and hardware failures. By analyzing power usage, temperature trends, sensor data, and fault history, DCM helps administrators identify and resolve CDU problems before they escalate. Finally, one of the most critical elements in today's data centers is server firmware. It is the foundational layer that affects reliability, performance, security, and compliance. Due to staggered purchases, many devices of the same model run different firmware versions. AMI DCM highlights these discrepancies across multi-device, multi-vendor environments to keep your AI infrastructure running smoothly and efficiently. As you can see here, we have 188 servers of this model being managed by this AMI DCM instance. Most of them are running an older firmware version on the management module, while a few are on newer versions, possibly because they were purchased more recently. This gives the administrator a clear signal that it might be time to bring the older units up to date. You can view firmware version details for all server subcomponents and see if a server model supports Redfish-based firmware updates, like this one. If supported, you can schedule updates to run immediately or at a specific time to reduce downtime. Redfish-based updates can also be performed in batches across servers of the same model, significantly reducing manual efforts and improving downtime management. Thank you for watching. You are now ready to use AMI DCM to manage dense and heterogeneous AI clusters and GPUs. Stay tuned for more videos, and for more information, visit our website or contact our sales team. Download your free trial version today.